Hey robot makers, hope you're having a good day so far. So do you want to learn how to make a fortune telling robot using a Raspberry Pi and a thermal printer? Then this is the show for you. So let's dive straight in. My name's Kevin. Come with me as we build robots, bring them to life with code and have a whole load of fun along the way. Okay, let's get over to our slides and we can see what this is all about. So yes, I've made a fortune telling robot. This is part of an exhibit I'm building for open source in San Francisco later this year in June. And it's based, as you might recognize, on the movie Big. So let's have a look at a bit more detail about this. So I'm calling this Voltara. So it's a fortune telling robot. It's based on, like I said, Zoltar, not Volta, from the movie Big with Tom Hanks. I think it's one of his first movies that he did. I remember this a long time ago. I think it's one of the first movies I saw as a teenager in a movie theatre. And this project is Raspberry Pi 4 powered, so I've got a whole bunch of Raspberry Pi 4s kind of laying around, and I thought this would be quite a good use to run the Python code that makes all the magic happen in this. And we're also going to use a feature of Unix, a fun game utility on Unix that's called Fortunes, based on fortune cookies, and the kind of fortune cookie-esque messages. They're so much fun. And of course we're going to use the thermal printer to print out the message, so what people will get is a little thermal printout like this that they can press the button, the arcade button on the front of the machine. Got these nice arcade style buttons from Pimoroni from the store, and they're very, very simple to get working. We'll have a look at those as well in a second or two. They'll press the button on the front, it'll print out a message and they can take that away. It also has like the web address of Kev's Robots on there too, and they can learn about it. So it's not quite finished yet as a project. You can see that the actual model isn't in there, and there's going to be a bit of animatronics in there. You'll move ahead and there'll be some lighting and so on. But that's kind of what we're going for. I've got a bit of a hoarse throat today, I'm afraid. So yes, this is for an interactive exhibit for Open Source 2024. So I'm really excited to go across to San Francisco. I think we're in the Cow Palace this year. And this is something that people can sort of see, they can touch, they can hear it perhaps. We're going to have some sound effects in there as well. Can't quite taste it. I mean, everything's tasteable, I guess, but yeah, that's not quite the sense we're going for there. And it's something fun. It's something I can show people. They can interact with it. So I'm not just kind of sat there with a big sign behind me doing nothing. So I thought it'd be quite fun as an interactive exhibit. And it's small enough for me to be able to ship this across to the UK. So I've actually from the UK to the US. So if I just go over to my desk here, this is the kind of size of it. It's not massive. It's quite small, as you can see. So it's probably about, I would say, 40 centimeters tall, something like that. So that's kind of what it looks like at the moment. So it was, like I said, inspired by Zoltar. Now, I was actually out having a family day out. I think it was your birthday, wasn't it, Alex? We went out to Mother Shipton's Cave, which is a really unusual exhibit in the UK. It's the oldest tourist attraction, open since 1630, which is ridiculous. And they have a petrifying well. It's very unusual. So water from a spring goes over these rocks, and it has minerals in there. And they have all kinds of things hanging down, like little teddy bears. And as the water passes through them over a series of about 3 to 4 months, they turn to stone. So it's a really, really magical kind of spooky place there. And they had in the little shop that they have where you can buy these teddy bears if you want. I think we've got a few of them. They had this Zoltar machine. So that's kind of a life-size version. It's not exactly screen accurate, this one here, but it was still quite a bit of fun there. So it was fun to see that, given that I knew I was building this. So yeah, that's something that we found just serendipitously. So yes, today's show is sponsored by PCBWay. So I want to give a great shout out to PCBWay, and I want to show you one of the projects I've worked on recently, which is, excuse me, this remote control. So this is a PCBW remote control, and I designed this in Fusion 360. So you can see on screen here, we have, if I go over to here, maybe go to this view here, you can see it a bit better. So design, essentially it has 8 buttons, so there's 4 on each side, and then there is the PCBW in the middle, and there is also a power connector there too at the bottom, so I can plug in a nice Pimoroni Gallium battery to power this. I think they're about 3.7 volts, something like that, but it goes through the little regulator at the top. As long as it's less than 5 volts, we're golden. So yes, I designed this circuit that you can see here in Fusion 360. Essentially they've taken over Eagle, what used to be Eagle, and now it's all part of Fusion 360. Excuse me, you then design a board layout. So I designed a 3D kind of profile for this in Fusion 360, and then you can drag on the components from your electronic diagram, and what you end up with then is the sort of 3D model. So you can see there, that's what the actual board looks like if you were to see the little traces and everything. So I simply exported this file as a Gerber file, and I went over to PCBWay's website, which I've got, if I just click over to here, we can see PCB's website, and we just click on the PCBWay instant quote, and I uploaded some of the files, the Gerber files that they call them there. So you simply, I think I picked the single panel. I think I went for 5 pieces. You type in the dimensions of the actual board if this was sort of a rectangle. I think this only has 2 layers, like a top and a bottom layer, so it's actually quite straightforward. I went for the simple FR4, and I think I left a lot of those defaults, and I actually went for the yellow board, and I think the silk screen I just went for white. And there is a solder mask on there as well, which I think is the is that the actual yellow colour perhaps on there. So yeah, very, very configurable, very easy to get exactly what you want, and you can choose what kind of finish you want on there as well. Once you've made all those choices, you can upload the Gerber file, which we've exported from Fusion 360. We can even have like flex rigid flex as it called, which is, there was like a bit like the PCB. I can't quite grab one's hand, but the I've seen people use these as like a magnetic flipper thing, so it can like vibrate very fast or something. I can't remember what they actually use that for now, but it was like quite a cool little thing. Anyway, you can basically have non-rigid PCBs. They can even assemble them for you. They can do SMB stencils. So if you want, if you're making loads of these, you can actually get the aluminium stencil, so you can put your own solder paste on and get it exactly in the right places. So you can manufacture these with a pick and place machine yourself, or you can have them do the entire fabrication if you want as well. And when I got mine sent over to me, there's one of them there. Like I said, I got a pack of 5. It was actually less than 2 weeks from me shipping this off, clicking the all the buttons on here and getting this sent back to me as a package. And it's very nicely rounded off, very nicely finished. Basically, you could sell these right away. So I'm very impressed with that as a whole system from start to finish. So definitely check them out. They're a great sponsor of the show. They've sponsored quite a few of the shows in the past as well, so thank you once again, PCBWay. Okay, next, so the 3D design of this model I've made. Excuse me, I'm just going to have a drink of water. I've used Fusion 360. I did try using FreeCAD, and I'm kind of still learning how to do things in FreeCAD. It's not quite as polished as Fusion 360, and I'm more familiar with that, so I basically did all this in Fusion 360. So there's the overall design. It's kind of like an arcade machine, but like a desktop sized one, and big enough for essentially like a Barbie doll to go in there, even though it's not going to be a Barbie doll, it's going to be a custom 3D printed model. And it has an arcade button. So on the original thing, they had a button that they pressed to, they get like 2 little things that he moved, a penny shooter into the mouth. Excuse me a second. Sorry about that. And yeah, it essentially we're having like an arcade button to activate this. On top of the button, the arcade button, is a thermal printer. So I bought this quite a while ago. I think it was from Adafruit. I'm certainly using all the Adafruit libraries to bring this to life with Python. But these are great pieces of electronics. They're very cheap. I think it's under $40 is what I paid for it. And you can buy all these refillable paper spools for them. They're essentially just receipt spools, and the paper contains the ink. So what happens is the thermal printer heats up the paper. There's no ink required, just the paper itself, and these stay around for a couple of years, so it doesn't fade that much over time. And I've got a few other bits and pieces on this to basically screw the whole thing together. The actual model, the head, has a tiny little mouth, so we're going to get it to do the Voltara head movement, which is like the chin stays still and the head sort of goes back. So we'll get it, and the eyes light up red. So This I think is a Corpse Bride model that I bought specifically for this project and scaled it down so it fits perfectly into this model. And we're also going to have some sort of furnishings, curtains and things behind it too. So here's a cutaway of the model. You can see there the thermal printer sort of goes into the to the front panel there, as does the arcade button. And I was really careful to measure these, and on the second print absolutely dialed it in really perfect. They fit in just right. So they basically just push into the to the front there, and friction holds them in place. It's such a nice fit there. I've got these corner pieces as well, which allow the M2 screws to hold everything together, and that adds a bit of extra stability. I could have gone with just the pieces with some sort of 3D printed extra bits there, but I wanted these to print flat with the front side sort of facing outwards. So yeah. I thought this was a nice way to add a bit of extra strength in there, is have these sort of corner columns, and it also ties the bottom pieces and the top pieces together too. So I've also got these screws, and they're slightly offset, so the idea is the screws can go in at an angle and they don't sort of clash together. So it's a very simple design decision there, just to make sure that you've got the extra strength of the screws. I bought a little pack of these, I'm not sure I put them now, but they're essentially just M2 screws with a nice hex nut to screw them in there. So the arcade button, very, very simple. They just have these two connectors on them there. If I sort of show this to the camera there, you can see there's just two little terminals there. It doesn't matter which one is to ground and which one is to the signal, as long as one of them goes to ground. We can then just pick that up in one of the GPIO pins on the Raspberry Pi. So very, very simple. I'll show you the code for that. It couldn't be easier to get working. The thermal printer actually uses UART, uses a receive and transmit. So all we need to do there is just use the UART on the Raspberry Pi. I'll show you the wiring of that in a second. But you do need to power this separately from the Raspberry Pi. So I bought a 5 volt 2 amp power supply separate for this. And I bought these nice little barrel jack connectors. So I think these are, is it 2.5 millimeter barrel jack connectors. And you can see there's a bunch of connectors. So the middle one is the one that's, if I show you that on the left-hand side there, and the two that are on the right are the sort of outside shield. So as long as the 5 volts goes to the middle, on this particular wiring and power supply that I've got, then we're golden, everything works fine there. And then the Raspberry Pi just connects to that, like I said, through two UART connectors. They're also on the back of the 3D printer. It comes with all the wires you need. You can get some of these which are USB, so you simply would just plug that into the front. But these ones are called TTL because it's 3 to 5 volts. But it plugs directly into the GPIOs. It's fine on there. So Raspberry Pi 4 is on the bottom of the machine there. I've designed the holes, the mounting holes on the back there. I've got holes for the USB power in, the HDMI 1 and 2, and also the audio jack. Now, I've also replaced this with a Raspberry Pi 5, and the audio jack would still be like, the hole would still be there, but there wouldn't actually be any audio jack there. But this was just in case I wanted to provide some external speakers and have some sound effects. It'd be very easy to do that too. I could also have a speaker inside there, but I've not placed any kind of grill or anything for the sort of sound to escape from in there. So the Raspberry Pi 4 essentially runs the Python script. It means it's very versatile. We can do all kinds of clever stuff with this. We could even have some like large language models if we wanted to, doing the fortunes locally on the device with Llama. But I thought for this particular one, I'll just use Fortune, which is this Unix game facility, library, routine, whatever. We'll have a play with that in a second. It's very, very versatile. So Fortune will send the message to the thermal printer in our Python code, and we can sort of top and tail that with a sort of header and footer as well, and maybe change the font size and underline and all that kind of good stuff as well on the printer. So I'm also going to animate the figure inside. So like I said, its head will move, and I've got these RGB LED strips as well, so I might put these sort of inside, maybe at the top and bottom, or maybe at the sides. I'm not quite decided on that yet. And also the arcade button just connects to the Raspberry Pi 4 as well. That then screws into the base. I've also got 4 extra holes underneath, just so that when I screw the Raspberry Pi in, it's not sort of wobbling on the case. There's screws at the 4 corners as well, just so it's nice and stable. Okay, so we decided to use resin as the glass because we could custom make this to the exact perfect size, and we wanted that top section to sort of be a slightly different colour, maybe like a yellow colour, but we can do that by just separating out or maybe just painting a bit of yellow on the inside of it. But these came out pretty well. On that camera, on that picture there, they look quite warped. They're not that bad actually. In real life, the light passes through them. They're very transparent and they look just like glass. We painted the entire frame. We've gone through a couple of challenges actually with the painting. So the top section we're quite pleased with. That's gold coloured. That looks really nice. The bottom section we went for like kind of a distressed blue and red scheme, but it ended up looking just like it very badly painted. So we've actually printed out the entire base again and repainted this sort of a black and distressed blue, and it looks so much better. We'll have a look on the screen in a minute in more detail. So this resin was a really great idea. It basically cured overnight, and we have a sort of mirror perfect flat finish on there. There's just on one of them a very slight ripple effect, but it looks great, and the light will basically bounce around inside this and also give an extra effect. It's much better than just having nothing there at all or having some kind of acetate. This makes it look a lot more real. So very, very simple. We had a silicone mat to pour the resin on, and the frames were sort of held down so that there was nowhere for the resin to escape. It did escape on a few of them, but it's very easy to sort of trim that off once we'd let that cure. So very easy to use this. Jenny helped do the painting and pouring the resin on that one as well. So you can just see that little... Yeah, shout out to Evan and Caitlin for giving us some advice on how to do that through their videos, not directly, of course. Cool. So the top section, so this is basically just like a little hat that goes on top. It just finishes the model. It will also help keep the light within and bounce around within the arcade machine. It also keeps any debris from sort of going into the model as well. So it just gives it a nice finishing touch, I think, too. So if you like what I do, you want me to make more of these kinds of videos, then please give this video a like, drop a comment, let me know if this is a fun project, if this is something you'd be interested in, and also tell me how many Raspberry Pis that you have in your drawer that you're not currently using. I'm always interested to know what people have in their drawer. If you've not already subscribed, please subscribe to the channel. It means an awful lot to me. This time of year, we do tend to take a bit of a dip in subscribers as people get outside and do more things rather than watching videos. So please don't be one of those people that doesn't subscribe. Please, if you haven't already subscribed, please give that a go. Okay, and I do go live every single Sunday. Last Sunday, I was really ill, so I couldn't go live, but I've soldiered on just for you guys today, so you can hear my throat's a little bit worse for wear, but hopefully we'll get through the show. So I do go live every single Sunday, 7 o'clock British summer time. Okay, so yes, painting the model. So we use these acrylic-based paints, and you can see there that silicone mat. We use that just to sort of paint on because it's just a nice clean surface to paint on. That's our little breakfast bar area there with a funky wallpaper. It's got like this UFO effect on there, little people being beamed up. So yeah, we chose the black and this metallic blue to sort of distress on as well. This is the effect that we used on Bubo. When I painted Bubo, we sprayed Bubo black and then we rubbed on a gold coloured distress. So you can put it on and then sort of wipe it around and wipe it off, and you get this nice kind of aged look to it. So yeah, just very simple acrylic paint because it's 3D printed plastic. And this was a piece, you can see there on the holes on there, it didn't have the audio jacks. This was the first back piece that I printed, and it didn't have that, so it didn't quite fit right. So we used this one as a test piece to try out 4 different ones. So we tried a few. We tried the metallic blue, which is the top left. We tried the metallic silver, which is the top right, and the metallic gold, which is the bottom right. Now you can't see too badly on this picture, but the top left is essentially what we went for there. On the other side of this was basically the blue colour with some black distress on it. It didn't quite look as good. You can see, in fact, the previous paint job on the top right there of the screen. So there's the blue silicone mat that we use for these. You can see that gold colour has a really nice sort of solid finish to this. So Jenny helped with painting those and doing a much better paint job than I did there. So wiring this up, so it's quite a simple wiring exercise. I use Fritzing to do this little wiring diagram because they had all the models in there, so that was nice and simple to do. So the arcade button is on GPIO 23. The pin next to that is actually a ground pin, so it's only the pin 23 that we need to look at it from a software point of view. Is it being pushed or not? And then the RX and TX on the Raspberry Pi Zero is on those sort of second and, well, third and fourth pin, depending if you count it 0 or 1. But yeah, for the left hand side where the SD card is, on the right hand side there, that's the UART pins. So this is the hardwired UART connection on the Raspberry Pi, and you actually have to go into the console. I can show you this in a minute if I remember. I'll actually just make a note of that just to make sure I don't forget that. So that's the Raspberry Pi. Yeah, so you actually have to switch off the serial console on the Raspberry Pi and enable the hardware serial connection, and then it appears as device serial 0 in your device tree. I'll show you that in the code in a minute. I've just made a note of that. So the thermal printer connects to that UART. It comes with these little header connectors already there, so you can actually plug that header connection directly into the Raspberry Pi, which is pretty neat. And it requires, like I said, 5 volts, 2 amps for the thermal printer. You can't actually run that from the Raspberry Pi. It'll basically just make it reboot because it'll pull too much power from the power supply, and it would damage this chip if you tried to do that through the pins directly. And I bought a whole bunch of these little barrel jack connectors. So these, I think, the 2.5mm barrel jacks, and they basically just have a bunch of connectors on the other end there. So I simply soldered that in, and they come with these little hex nuts. I'll just grab one of those there. So you get these little hex nuts, and you can basically just screw that through. So as long as the 3D printed piece, you push this on and then thread the hex nut on to the end, that will basically hold it in place nice and secure. The best connection, honestly, when things just work right. Really, really pleased with this. They're an interesting kind of shape because they're a circle with the edge chopped off. So I modelled that in the 3D model, and honestly, it just pushed in first time, connected up, no problem. So I soldered the wires on, pushed it through, put the hex nut on, locked into place. Lovely. Okay. Code. So obviously this is Python, so I'm going to show you the code that I made just to make this thing sort of work. I've used the serial connection, which is a standard Python thing. If you have a Raspberry Pi, I think you just install PySerial to get that. And I've also made my own library that's called Voltara. I'll show you the code for that. And I've borrowed the Adafruit thermal printer library. They no longer support thermal printers. I don't think they sell them anymore, but you can still use their code. It works fine in Python. So what we need to do to set that up, we have to pass it the device connection, so /dev/serial0. Once we've done the Raspberry Pi stuff, I'll show you in a minute to configure that. The baud rate. This is important if you're wanting to use this as like a general printer. I'll show you some of the challenges with that. But that 19200 is quite a fast speed. You can have some issues with sending too much data at once, and basically the image won't print out properly if you're trying to print like some kind of graphic out. And then there's like a timeout value as well. I think that's in like milliseconds. You can then actually change how fast the printer connects. This set times 3500 and 2100. These are some values for printing out like things like images to sort of slow down. The reason that there are challenges with this is the thermal printer is pretty dumb. It has a memory buffer, and if you put too much data in that buffer, it'll just overrun, and you'll basically get loads of garbage in the file, and then the rest of the image will just print out. So you kind of get the beginning garbage and then the end. So by changing these printer times, you're actually sort of saying to the thermal printer can say back, stop, slow down, only send me a bit of data at a time. So you're managing how quickly that buffer fills up. That's kind of what that's for. Printer.feed will actually do line feed, so it spits out more paper. The button.wait for press is a really cool button function. I think that's, we'll have a look where that comes from in a second. I'll show you the code for that. But essentially, the arcade button, the code will stop until you press that, and then it will just run the next piece of code in there, which will feed 2 lines. It will set the underline value on. So on our little printout there, if I just show you this, this is what will actually come out. So You can see that top piece there, if I try and get that so it doesn't white out, that's double height, so the size is medium, I think, on there. It's got an underline value there, so that the whole thing is underlined. It's also centered on the page, which is pretty neat. It then prints out that Voltara fortune teller, does 2 lines after that. We then switch off the underline, set the size back to small, set the justification to the left-hand side. We print 2 more lines, and then we say, your wish is granted. Now, this is the area of the code where we'll actually put in the fortune cookie, so it won't just say your wish is granted on the final version of this. And then it will do a couple of lines, and then it'll just say kesrobots.com/Voltara. So it couldn't be simpler, the code, mainly because the Adafruit thermal printer library does a lot of that heavy lifting for us. So, well, let's have a bit of a play with the fortunes in Unix, shall we? So I'm just going to grab my, let's go full screen on this, and let me just flick back. It does this weird thing on there. There we go. Let's go back to here. Right, so I'll make this a bit larger so we can actually see what's going on. I think there's a zoom in function there. So I didn't need to grab the window to zoom in. I could have just let it zoom in itself. Okay, so hopefully that's visible. So to install fortunes on the Raspberry Pi, we simply we can install this through the apt. So we do sudo apt install fortunes, and we can also do fortunes-mod, and this is actually the data files that have all the fortunes in them. Was it fortune mod? I think it might be on there. Yeah, we've already got them all installed on there. So, and then the other thing we need to do to get the thermal printer working, I'll just show you that. So if we do sudo raspi-config, this is the Raspberry Pi configuration utility. We'll go to the interface options, and we've got this serial port. So we need to make sure that we don't make the shell accessible over serial, and that we do enable the hardware in there as well. So I'm going to click that, I'm going to click finish. And what that means is if I do lsdev, this is the device folder, and if I do serial 0, that now exists as a path, and anything that we send to that will print out of our printer. So I'll actually show you that. If I go over to, let's see, if I do this one here, so you can see in the top left window there, if I type echo, in fact, let's go full screen just for a second, echo hello live streamers, and then I pipe that into /dev/serial 0. Now before I press return, it's going to go back here, so watch this here. I press return and it spat out a little line there. So if I now, I'll have to just juggle this up a second just by, can you see what that says on that piece of paper there? Let me tear it off, put it onto the camera. Let's see if I can get that so you can see it. It says hello live streamers. It might be easier to show you on this full camera here. There we go. So it's very, very easy to actually print things out. Now let's go back to, let's go back over here, and let's let's now do some fortunes. If I just type in fortune, it doesn't know where the fortune data files are. So there's a whole bunch of these that got installed when we installed fortunes. If I go lists and then shared games, I think it's shared games. I wonder why it's not. Is it share games fortunes? There we go. So all these files here are the fortunes themselves. So they're actually like a data file that's got loads of different saying quotes in there. So I think there's one in there that's called humor. So if we do fortune and then we pass it that path, so share games fortunes and then computer. Well, let's try a different one. Actually, that one didn't work. Let's try, is it Linux? Did I not type Linux correctly then? There we go. So we've got a fortune. It says, I did this because Linux gives me a word, gives me, what? Let's try a different one. What is the status of Linux Unicode implementation? Will Linux be prepared for first contact? We have full Klingon console support just in case. So some of the jokes are not very good. Let's try that computers one again. If I just let it auto, there we go, computers. When Dexter's on the internet, how can we... Can hell be far behind? So some of these are funny, some of them are not. I think there's a humour one, actually. Let's try humour. Humorists. Time is illusion, lunchtime doubly so. That's a Hitchhiker's Guide one. What else we got that? Now you can do like long ones, short ones. There is like an obscene or non-obscene options on here as well. I think it's like -O or something like that. Or is it -E? I can't remember. Or it might actually be the files themselves. But yeah, there's a whole bunch of these. If we just go and do that list again, let's see what else we've got. So we've got food. Let's try a food one. So let's go back there. Food. Trouble eating Italian food is that 5 or 6 days later you're hungry again. Let's try another one. National Association of Theatre Concessionaires report that in 1986, 60% of all candy sold in movie theatres was sold to Russia. So, that's the fortune thing. That's what we're going to actually use. I'm just eating some ice there. That's what we're actually going to use in our code to generate these kind of fortune cookies, and there's a whole bunch of them. There's even libraries of these on the internet that you can download that are not included in this fortunes. But honestly, you could run this and never see the same twice in your entire life. It's pretty cool. So let's go over to Visual Studio Code, and what we're going to look at next is how to get that arcade button working. So I might have just dropped one then. So I've got an arcade button here. This is a nice black one, and it just has these two connectors on there. They're connected up to ground and to GPIO 23. So if we import from GPIO 0 and import the button function, we can then simply say button equals button and then provide that GPIO number, and that's it. There's a button.wait for press. So if I run this code, it's not going to do anything until I press the button. Oh, I'm actually running the code, I think, on another screen. So if I just go and quit that, there we go. Let's just try that again. So what I will do, I'll try and get everything on the screen at the same time. So if I run that code again, so it's waiting for me to press the button. If I press the button and then zoom back into that thing there, you can see that it says... When I get back to the right screen, sorry, you can see that it says button press. If I just run that again, there we go, and I press the button, I'm pressing the button now, it says button pressed. So very, very simple code. It kind of halts any code beneath that. Once a button's been pressed, it kind of releases it, and then you can do whatever you need to do next. Right, next up we're going to have a look at printer tests. So this is going to print out some tests of our printer, what it can do. So I'm using the Adafruit thermal printer library. So I did have to do pip install Adafruit_thermal to get this library installed onto my machine. I'm then setting up a printer object that's called printer equals Adafruit thermal, the path to the serial console out, which is what the thermal printer is connected to. Excuse me, the baud rate. Now this baud rate here has to match the baud rate that the terminal device is set to, and you can actually set this with the set STTY, and then I think you just provide the path to it, so like dev serial 0, and then you provide the value that you want that to be. I think that's correct. Let me just see if I just do man. In fact, if I do that, will it tell me what it needs to be? So if I do STTY serial 0. Dev serial 0. No, I probably just need to read the manual page. If you're ever stuck in Unix and you want to know what the options are, there's a couple of ways you can do this. You can have a look at the manual for it. So if I do man STTY, this is a sort of full manual for that command. So I can just scroll down there and see what I need it to be, and they'll give you an example, if I just keep scrolling down on here, of how to type in the commands. If there's a lot of commands, it might take a while to sort of scroll down, so I'm just doing page down now. Let's have a see. Has it not got an example on there? That would really be helpful if it did. because I'm sort of viewing this in like a very small thing, it's not that easy to see what's going on. The alternative to man is if you actually type in the command and then do -- help, that usually provides the help that you need as well. So this might actually provide the example that I was looking for there, but essentially STTY is the command that you need to do to set the baud rate for that terminal device from the console, and it should remain there once you've set that. You don't need to do it each time you reboot the machine, for example. Okay, so there you go, -F, that's all I was missing there. So if I did -F, in fact, let's just type it in. So if I just do STTY -F and then dev serial 0 and then 19200, that's now set to be 19200. So the baud rate is now matched to the serial printer itself in our code. The next thing is this printing. We don't actually need that set times because we're not printing out any images in our final code. But on this particular piece of code, this thermal printer test one, we're going to print out the Adafruit logo because they provide that as a little graphic in the graphics folder. So if we open up that, have a look what that looks like. They've got a height and a width, and they've also got this data. So if you were to sort of squint your eyes and look at this, this is actually the sort of little flower. Is it like a pentagonal shape that is their logo? So that's what's going to be printed when we do the print test. It's going to feed 2 lines after printing that bitmap. It's going to sleep, wake up, and then set the defaults, whatever they were. So if we've changed around any of the font sizes and so on, it can change that back there. So if I now press print on here, and I jump over to the overhead thing there, can you see the little flower thing that's printed out there? There is this nice button on the front of the 3D printer, the thermal printer. If I just press that a number of times, I can get that to squirt out some extra pages, but I can also just tear that off. Okay, let's go back over to the full screen there. You can see what that looks like. So it's actually pretty neat, isn't it? You can see there quite a lot of resolution for what is quite a simple device. So that's the printer test. And then let's have a look at our code. So I've made this code a little bit more involved, but not too much more involved. So we've got this while loop. So while there's no keyboard interrupt, we're not going to press anything. We wait for the button to be pressed on the front of our arcade machine. We feed 5 lines out. We set the underline on, so it has that underline because we want to print out this message with the underline. We then want to set the size to be medium. Set the justification to center, print out the Voltara fortune teller. The /n/n is new line. You'll see that in if you're using like Arduino, C++, that kind of thing, but it's a quite usual convention for doing new lines. These // are called escape codes. And thanks for subscribing there, Joey. Escape codes, if I just switch that off so it just doesn't disrupt us again. Escape codes are special characters. They usually have the escape character, which is like a really low value in ASCII, the American Standard Code for Information Interchange, which is like a standard for displaying characters, and there's only essentially 255 characters within that code. So escape characters are a way of sending special signals to things like this thermal printer. So the way that we're setting the medium or the small, the underline, the non-underline, there's even an inverted where it makes it prints out black with a white text on it. They're all special escape codes, and new lines are essentially just another escape code on there. So there we go. Line feed off, set the size to standard, justification to left, feed 2 lines, print your wishes granted, feed 2 more lines, do the underscores like another ruler, and then we can do the actual message itself. Feed 4 more lines, and then we just reset the printer to its default values again. We could do that default thing. So if I now press run, and I run this code on the right screen there, so now it's waiting for me to press the button. Now, I've actually not got any code in here to stop multiple prints from happening. So if I hold that button for too long, and the code goes around the loop again, it will print out the same thing again and again. So let's go to our printer. I think this is probably the best view of it. And if I press the button, as soon as I press it, we get the thing being printed out there. And if I tear that and show you that piece of paper there, you can see there it says Voltara fortune teller, your wish is granted, and then the kesrobots.com/Voltara, which is kind of going off the page a little bit. So maybe we need to play around with the font sizes on that one to make that one a bit more easily to view. Cool. So let's get back to over here. So we've had a play with the fortunes. So some of the challenges we've had with this project so far. So there's always challenges, and some of the things I like to share these things just so that I can look back and figure out how I did something last time. But also, if you're having the same kind of problems, you can have a look at this and see what the answer is too. So the thermal printer I've had lots of failed prints with this, particularly if I'm doing graphics printing. So you can actually print. If I go back to that terminal there, let me just end that program. In fact, let's go back to there. I'm using Visual Studio Code. I'm actually connected via SSH, which is pretty cool. So this is actually running on the Mac. So if I just do Control-C to come out of this, I can actually print out a graphic, like a proper PNG file, something like that. Just seeing if I've actually got any of them to hand, actually. I did have some. There we go. Voltara Speaks. So Voltara Speaks is actually... if I find that, I think it was in utilities, it's a PNG file, so that's what it says. I want to put this at the end of the printout. So you can actually do a line printer. If you can do LP, is it fit to, I can't remember the exact thing on here, fit to something or other. Size, is it? This may or may not work. I don't think we provide the path of the file. It's been a while since I've done this, so what I'm going to do, I'm just going to type in history, and that will show me all my Unix history commands, if I can actually type in history correctly, and then we can find that. Just ignore that for now. So I'm just looking for an LP command on here, because that means I've done this previously and it worked. There we go. Ah, there we go. So that's all I need to type. So this line printer, LP-out, -0, I think that's -O is output, fit to print, which is the option. We want it to fit this JPEG to the printer size, and we're passing it the PNG file. So if I do that, no file or directory, that's because it's inside that folder. So in fact, I think it's got a different name, hasn't it? Voltara Speaks. If I put that into speech marks, that might make it work. No, it's because there's a typo. It says Voltara. There we go. Right, so it's printing that out, and I want you to see what this looks like on here. You see, it's just like loads of garbage, and there is actually some bits of. If I go full screen on this one again, look what's happened there. So we've got all kinds of weird characters, and you can see that there's part of the image is in there. And this is a buffer overrun, and this is because the line printer isn't waiting for the printer to catch up, it's just sending the entire file all at once. So we can change this by changing the line printer speed and also the terminal speed, so we can actually slow down how much data is being sent there. So we could try using that command that we tried before, which was the in the wrong window there, which was the STTY, and we can slow down. We could do 9600 instead of 19200, which is much faster speed. So if we slow it down, it'll take longer for that buffer to fill up, and hopefully it'll print it and used up some of that buffer, so we don't get that kind of image. So if you've got one of these thermal printers, you follow some of these instructions, and you get this kind of thing happening, it's to do with that buffer overrun, and the only real way to deal with that is slowing down the baud rate, is my findings. So the print speed as well, it's quite slow when it's printing images, and this is because text is like really small, so it's just like a single byte per character. If you're sending graphics data, that's like a lot of data, so it actually takes longer for the buffer and the processor on the little 3D printer to chew through that. So they're not massively fast. If you're printing out graphics on this, it'll take a little while. That's why things like that Adafruit logo are really small, because then it's quicker to print, and it's like not taking as much of the page up. The other thing is the power. So if you've not got 2 amps or more going to this thermal printer, you might find that it grays out, or that it kind of reboots in the middle of printing something out, because it's heating up the paper and it takes quite a lot of power to make that little thermal printer work. I'm quite curious. I bought, I'm not sure if I've got it to hand actually. I bought a little thermal printer, which is kind of a handheld battery powered Bluetooth one. And that just requires like a couple of AA batteries, or I even have a LiPo battery built in. So I'm quite impressed that they managed to get that much power out of their little pocket thermal printer. And that uses the exact same pieces of, I think these ones were the ones I got for that, but these are all the standard size. So the sort of length of these is identical. And they're very cheap to buy, so you can buy absolutely tons of these because they're basically used all over the world for receipts. Painting, so we had quite a difficulty getting the painting just right on our model, because we wanted to get a particular look which is like an aged old, if you think about the movie Big, this was like an old arcade machine that was on a pier somewhere. We wanted to get that kind of same kind of look to it, so that isn't easy to do off the bat. So we basically tried putting some colour on and then distressing with black. That basically looked a lot messy, didn't really look like a distress, it just looked like badly painted. So we tried the other way around, we painted it black and then used the colour to highlight it, and that looked far better. And that's what we did for Bubo, which is the steampunk robot. If you've not seen that, definitely check that out on the channel as well. Okay, so we do have some merch on the channel. So if you want to get yourself one of these hats, we've got them in a number of different colours. There's the red one that seems to be very controversial to people in the US. I can't imagine why. So that's why I'm wearing a black one now instead. Sorry for the vocal fry, that's just today's vibe, I'm afraid. We've also got some mugs as well on there, some hoodies and whatnot. So definitely check out the merch store if you want to help support the show. Now there was a question in the, or a comment in there from Peter, and it's quite a useful one actually. So I'm just going to go back over to the Raspberry Pi. You can actually install this as a printer. So is it preferences actually? Preferences, printer settings. You can add this as a printer and you can share this on your network, which is pretty cool. So you can see there's my HP printers, but look at this ZJ58. So I went to add new printer, ZJ58, and you connect the serial 0 or TTYS0, which is the same thing essentially. And you can set some settings in there. So if I wait for that to load up, and these are the settings that I've gone with. So I've got the baud rate is 19200, the parity is default, the bit rates are default, but the flow control is X on, X off in software. You've got a few different choices in there. That's the one I've gone with. That's also part of how it sends and receives data, and it's all done in software. Peter just mentioned that about the flow control and how printers, especially these old serial printers, control the flow of that. But the cool thing is you can actually have this as a printer that you can do things like I can do a test print page there. That's now going to print out. If I go back to that view there, it's printed some garbage because it's tried to print a bit of an image. You can see the image overrun there, buffer overflow, sorry. So we can fix that by reducing the baud rate down a little bit and just seeing if that works okay. We need to do that both in the printer settings and also on the terminal using that STTY command we looked at before. So thanks Peter for just highlighting that. That's quite a good talking point there. Okay, if you want to join our Discord server, we have a Discord server. Head over to kevsrobots.com/discord and you'll be able to find all the cool things on there. There's a really growing community of people helping each other out. And another thing I wanted to mention about kevsrobots.com, if I go back over to here, kevsrobots.com is now ad-free. So I've taken off the Google ads, so you're not going to get any of those disrupting your use of the website. You don't have to have any ad blockers or anything. It was generating a bit of revenue to pay for itself because I do have things like the privacy policy, terms and conditions, disclaimer. They're provided by a company called Termly, and you do have to pay for that as a service. And the whole website is also, as well as being hosted behind me on my little Raspberry Pis just behind my head there, you can just see them flickering away. We use Cloudflare to provide some denial of service protection on top of that and to get some stats and whatnot. That's not free either. So, so the ads were actually helping pay for that, but they were actually getting in the way, and I decided I'll just suck that up instead, so you get a better experience when you're trying to find things on here. Another cool thing we've just added very recently, I've not got an easy link to this yet. If I go down to, let's see, I go to one of these projects. Nope, not that one, sorry. That's a YouTube video. That's not what I wanted to show. Let's try, what am I trying to show you here? I'm trying to show you the link to the STEM resources, which is something new that we've added in here. Let's try going to one of these projects. No, that's not. I'm fiddling about here and I'm not getting where I need to go to. If I can't find it, I'll give up and I'll come back. So essentially, if we go to kevsrobots.com/STEM, there's a new area which is the STEM Centre, and we've got things like connectors. So if you want to learn about connectors and all the different types of connectors for plugging in, I don't know why it's jumped to that particular one there, but yeah, there we go, that's better. So connectors, DuPont connectors, Grove connectors, JST, do you know what JST stands for? If you click through there, you'll find out. So I've got Molex. I just need to add in some quick STEMMA QT connectors in there, and I think the article's then pretty much complete. There's a whole bunch in there about I2C, SPI, and UART as well. So UART's what we're using today to do the thermal printer connection. So it's got a bit of information about that as well. So that's a new area, the STEM Centre, that we've added to the site as well. We're sort of building that out too. But yeah, kevsrobots.com is now completely ad-free, so I just wanted to mention that too. If you want to follow me on social media, you can do this a number of different ways. So if you go to Threads, I'm on Kevin McAleer at threads.net. I'm on TikTok at KevMcAleer6. I'm on Instagram at Kevin McAleer. We had a video blow up actually, Alex, this week on Instagram. I think it's had over 20,000 views so far, which is crazy for one of my videos. And I can't remember which one that was now, but it was one that didn't seem to be worthy of 20,000 views, but Instagram shone its light on it and has picked it up. I'm also on X at KevsMac, on Mastodon at KevsMac at mastodon.social, on Blue Sky at KevsMac at bsky.social as well. So if you're on any of those platforms, definitely follow me on there, say hi, let me see what kind of projects you're working on. I'm always interested to see what people are building, particularly if it's robot related or even Raspberry Pi related. And if you want to support the show, you can do this in a number of different ways. So I just want to give a shout out to Ford, who just dropped some dollars there saying good show this week. Thank you very much for that. I do appreciate that. So he did a super chat, which sort of pops up on the screen. So thank you so much for doing that. I'm just going to make sure we've got all those switched on again now as well. And yes, we have a YouTube membership program as well. So if I scroll back up there, I can also just pop up that on screen. So that's thanks Ford for sending that through. Really appreciate your comment there. And if you want to join the YouTube membership program, you can do that simply by clicking the join button. So once you've subscribed, that gets replaced by a join button. You can press that, and for the price of a coffee per month, you can help support the show and help pay for things like that website, which I now pay for myself. Cool. Oops, let me just jump back there. And yes, our supporters. I want to give a shout out to people who have joined all those different programs I've just talked about there. So I got a coffee this week from Tom. Thank you, Tom, for that. I think he particularly appreciated one of the videos that we shared this week. Last week, I think it was. We've got Johnny there as well. He bought coffee, and we've got a number of members as well. So on the Buy Me a Coffee side, we've got Shemi, we've got Kevin, we've got Lee, Alvaro, Marie, Jeff, we've got Dean Corty, Marlene, Tom, and Steve. And on the YouTube membership side, we've had Alrondo. If I pronounce that right, I can't pronounce that now. Alwaldo Calvajo, he joined very recently as well. We've got Paul, Johnny, Dale from Hybrid Robotics, we've got Wayne, we have Stephen, we have Jonathan, we have Orkstrad39, Vince, John Paul, we've got Alistair, Cassie. Hope things are going okay, Cassie, and you're recovering nicely there as well. We've got Tinkering Rocks, JDM, Johnny Bates, we have Hans from Chairlights, Michael, and of course we have Tom as well, our longest follower. So yes, that's everybody I wanted to give a shout out to, and I think that's the everything I wanted to cover off in the main show today. I managed to make it through with my voice not being too badly blown out today. the water definitely helps there as well. It's just ice water. Cool. So this is the point in the video where you hopefully get a recommendation over here for a video from our channel, and check that out. That's as good as subscribing, because it helps the YouTube algorithm know that you like my content and you're binging it, which is good. But this is the point in the video. If you're watching on replay, I'll say thank you so much for watching, and I shall see you next time.